Today I am going to teach you about the principle of shear stress. First, you have to know what is shear stress. Shear stress or shear stress is also known as transverse stress. First, you have to know the definition. First, to go through the definition of shear stress. Now, shear stress or transverse stress is the measure of the angle through which a body is distorted by the applied force. We have to do you and we have to know about distortion means the inclination of you can see there on this figure there is an inclination at this point. This inclination you can see here at this angle. The force acting at the stress acting at this inclined plane is known as shear stress. The and we have to know we know the formula of shear stress, F force by area. So at this after and what is the force acting at this surface? So first we have to know what is the area of at this surface. To finding the area of at this surface, we have to go through mathematical formula. Cos theta is equal to SR by ST. It means cos theta B by H and base upon hypotenuse. So S by ST. The cos theta is equal to what is the SR? SR means the area of in this surface is A. So we put there A and we have to find the area of at this surface. So and it means ST. So at ST is equal to A by cos theta. Similarly, hence stress is equal to F by A. F is equal to sigma into A. Consider this equation as first. Now the normal force is equal to sigma n into A by cos theta. The force at this surface seen in this figure. This have you seen this diagram? There is a normal stress is acting at the surface. So we should find first the force acting at the surface. The force is stress into area. So what is the stress acting at this point? Sigma n and again normal stress. It means normal stress. The normal stress into area at the surface. So we after putting the area we get this value. Normal force is equal to sigma n into A by cos theta. Similarly, shear stress is acting inclinedly. So at inclination, shear force is equal to shear stress into area. So area at that surface is A by cos theta. After putting this, we get this. After go through the balancing condition, have you seen this figure? This force is balanced by this force. It means normal force is balanced by this P cos theta force, and this shear force is balanced by P sin theta. So after in balancing condition, P cos theta is equal to normal force. What is the normal force? We put this value here, sigma n into A by cos theta. After solving this, we have to find shear stress. After this solving, we will get the shear stress is P times of cos theta by A into cos theta. After solving, normal stress is equal to P by A cos square theta. But this will be acting in x direction. This is x direction and x direction and y direction, and this force is acting along the x direction. So we shall let sigma x is equal to p by a, and normal stress is equal to sigma x, because this stress is acting along the x axis. So normal stress is equal to sigma x into cos square theta. Similarly, p sin theta balancing the shear stress. So shear, what is the shear stress? Shear stress is shear stress into a by cos theta. And similarly this we solving this shear stress is equal to p by 2a into sin 2a, and this is also, and this shear stress is also acting along the x direction. So we shall let we shall let sigma x is equal to p by 2a, p by a. So shear stress is equal to sigma x by 2 into sin 2 theta. Similarly, there is a two case arises. One is maximum normal stress, and another is, in second case, we should find maximum shear stress. First, maximum, at what value of at what value we will get the maximum normal stress. By seeing this formula of normal stress, there is a cos theta, and it means that there is a most important role of in this formula. This angle is most important to find the maximum and minimum value. So for maximum normal stress, what is the value of at what value of theta we will get the maximum normal stress. So what is the maximum and minimum value of cos theta? 0 and 1. So maximum we are then what is the maximum value? 1 is the maximum value of cos theta, and 0 is the minimum value, and here we are finding the maximum value. So we take 1, and then what is the and 1 I was finding theta is equal to 0. What is the value at what degree? The value of cos theta is 1 at 0 degree. So after putting the 0 degree here, we get the maximum normal stress. The maximum normal stress is p by a, and then what is the shear stress at maximum normal stress? Then it is 0. The sin 0 is 0. So normal shear stress is 0 at in this case. And now seeing in second case, for maximum shear stress, and in this formula, after seeing this formula, normal shear stress is, there is sin theta. So what is the value, maximum and minimum value of sin theta is 1 and 0, similar as cos theta. So 1 is maximum value and 0 is minimum value. So after taking 1 is the maximum value. So theta is, we get the theta as 45 degree, because there is sin 2 theta, and theta is equal to 45 degree. So after putting this value in this equation, the shear stress is equal to p by 2a into sin 2 into 45 degree. It means 90 degree, and sin 90 degree is 1. So shear stress is equal to p by 2a. This is the maximum value of shear stress. And normal stress in this case is p by a into 1 by root under 2 whole square. In this case, normal stress is not 0 but nearly equal to 0.